In this next example, we're asked to graph quadratic relations as well. What makes this example different from the other is that the zeros are not distinct, they're one and the same. That means the vertex is going to be sitting on the x-axis, and the vertex will be an x-intercept as well. So how do we graph questions like this? Well, first we can determine the x-intercept or the vertex. That's step one. So if I look at the relation y is equal to 2 times x minus 5 times x minus 5, the vertex or x-intercept is going to be 5, 0, because an x value of 5 would make the y-coordinate 0. Now that I have the vertex, I need to find two other points on either side of the vertex. One of the points that we're going to use is the y-intercept. To find the y-intercept, you set x equal to 0. So I'm going to sub in 0 wherever I see x, and then I'm going to evaluate. And I end up with 50. So the y-intercept will end up having the coordinates 0, 50. So I have a vertex and I have another point, which is the y-intercept. And at this point, I'm going to plot those 2 points. And I'll put 5 here. I'm scaling the x-axis by 2.5 units, but you can scale it by whatever you want. And I'm going to scale the y-axis by 10 units. And now I'm going to plot my vertex, which is also my x-intercept or 0. I'm going to plot the y-intercept over here, and I have 2 points that will be on this parabola. To find the third point, I'm going to use symmetry. I should have another point with a y-coordinate of 50 on the opposite side of the axis of symmetry. That's the same distance away from the axis of symmetry as the y-intercept. So this distance is 5 units here. So the point to the right of the axis of symmetry will be an additional 5 units away. That means it will have an x-coordinate of 10 and a y-coordinate of 50. And now I'm going to draw a parabola through those points. And that would be my final parabola. Okay, let's look at another example just like this. Okay, first step again, determine the vertex. What value of x will make each factor equal to 0? And it will be -6. So the coordinates of the vertex will be -6, 0. Second step, we're going to find the y-intercept by setting x equal to 0. Okay, so now evaluating 4 times 6 times 6 gives me 144. So the y-intercept will have the coordinates 0, 144. Now I'm ready to graph. And this -6 here, it's my vertex. Over here at 144, that's my y-intercept. This time the y-intercept is to the right of my vertex. So I need a point to the left of the vertex on the other side of the axis of symmetry. So if the y-intercept is 6 units away from the axis of symmetry, but it's to the right, I have to go 6 units to the left to get the third point, and it will have the same y-coordinate as the y-intercept. So the third point will be at coordinates -12, 144. And then I just draw a smooth curve through the points. And there's the parabola.